Hello students, good morning. So today we are going to start with the series RC circuit. So basically when a resistor and a capacitor are connected in series, then it is termed as series RC circuit. Here AC supply is connected, this is R, this is C, and this is V equal to Vm sine omega t. Here single phase AC supply, so voltage will be 230 volt and frequency will be 50 hertz. Okay, all these parameters are connected with a AC circuit. So here a resistor and a capacitor are connected in series. So what will be the phasor diagram? Here again in series current will remain same, so current is same. Now what will be the phasor diagram? Let's take current as a reference phasor, so it will be I. Voltage VR will be in the same phase as in current, so this is VR. Now what will be the significance of VC? The voltage across capacitor. VC is what? Voltage across capacitor. As in my previous video, when circuit is having only capacitor, we have discussed that in purely capacitive circuit, the current will lead the voltage by 90 degree, or in other words, we can say that voltage will lag the current by 90 degrees. So here the VC voltage will lag the current, so it will be the VC. And what will be the resultant? This will be the resultant V voltage. Here this VR will be equal to I into R, this VC will be equal to I into XC, and this will be equal to V equal to I into Z. Clear? Now if I will write V, then V will be equal to again VR square plus VC square, or we can write V equal to VR minus J VC. What is the meaning of this statement? Here J is showing that, here J is what showing? J is showing that 90 degree phase difference, 90 degree phase difference between V and I in case of capacitor, in case of capacitor. Clear? And this negative sign is showing that, why we are using this negative sign? Voltage is lagging with current, or you can say VC is lagging by current or voltage across resistor by 90 degree. So J is representing 90 degree and negative sign representing lagging. So basically you can write voltage in this form also. From here we can draw the impedance triangle also. So impedance triangle will be equal to like this. This will be R and this will be XC, and here you can draw the impedance Z. So Z will be equal to R minus J XC. Clear? Or Z will be equal to under root R square plus XC square. So this is the simple voltage triangle and power triangle. Now we can see that voltage is lagging. If I will draw this phasor diagram again, having only current and voltage, so it will be current and it will be voltage. So here we can see that voltage is lagging the current by some angle phi. So what I can write for current? It means current is leading the voltage by some angle phi. So equation of current will be equal to Im sine omega t plus phi. In the case of RL series circuit, we have written that I will be equal to Im sine omega t minus phi. But here current is leading the voltage by some angle phi. From this phasor diagram, we can see that current is leading the voltage. So current will be equal to I equal to Im sine omega t plus phi. So there will be a plus phi. Now What will be the power? What will be the power? So power will be equal to V into I. So V is what? V equal to Vm sine omega t. And current is what? Current is Im sine omega t plus phi. So again, Vm Im sine omega t plus phi. Okay, we can write same in case of RL series circuit. Similar here, the same procedure can be followed. Sine omega t plus phi. Now what will be the average power after solving it? P average will be equal to Vm Im by 2 cos phi. So you can write Vrms Irms cos phi. This will be the average power. Clear? Or alternately you can calculate from the other method also. So what can be the other method? P you can write power in R plus power in C. So power in R will be equal to I square R, and power in C will be equal to 0, as we have discussed that average power for capacitive circuit will be 0, and for inductive circuit it will be I square R. So IR into I. Clear? At the place of I you can write V by Z. Clear? Now modify it. Now modify this expression, V into I into R upon Z. This R upon Z is termed as cos phi, power factor. So power factor will be equal to cos phi R by Z. Okay, and this is P as we have obtained earlier. This is same. Clear? So this is the scenario of series RC circuit. Again, in this case you can also draw the power triangle. When we are having voltage and current, we can draw power triangle very easily. Clear? Now let's do some numerical. The question is like, we are having a capacitor. C is given 79.5 microfarad. C is given 79 microfarad. Is connected in series with a non-inductive resistance of R is equal to given 30 ohm, and voltage is given 100 volt, frequency is given 50 hertz. Now what we have to calculate? We have to calculate impedance. Second one is current. Third one is phase angle. Fourth one is equation of the instantaneous value of current. Equation of current. All these four values we have to calculate. So first of all, what I will calculate? Xc. Xc is what? 1 upon 2 by Fc. So 1 upon 2 by F is 50 into C is 79.5 microfarad. So what will be the value of Xc? On solving it, I will get 40 ohm. R is already given. R is what? 30 ohm. So what will be the impedance? Z will be equal to R square plus Xc square under root 30 square plus 40 square. So what I will get? I will get 50 ohm. This will be the Z impedance, 50 ohm. Now next is current. Current will be equal to what? I will be equal to V by Z. So what is V? V is 100 volt, and what is Z? We have obtained 50. So what will be the value of current? 2 ampere. So this will be the current, 2 ampere. Now next is phase angle. Phase angle tan phi will be equal to XC upon R. So phi will be equal to tan inverse XC by R. So what is XC? Tan inverse 40 by 30. So it will be equal to 53.03 degree. And what will be the nature? It will be leading nature, because we are having RC series circuit. So in RC series circuit, the current will lead the voltage. Now next is equation of current. So what will be the equation of current? Im will be equal to what? The Im you have calculated. So IRMS is what? 2 ampere we have calculated and multiplied by root 2. So current will be 2.828 ampere maximum current. So I equal to Im sine omega t plus phi in capacitive circuit, resistive and capacitive series circuit. So Im 2.828 multiplied by sine omega t plus what is angle? 53.03 degree. So this will be the expression for instantaneous value of current. Here, when you will get the value of time, you can calculate the value of current at that instant of time. Clear? Let's do one more question. What is given? It is given that we are having a circuit. In this circuit, R is given 10 ohm and C is given 400 microfarad, and supply voltage is what? Supply voltage is given 60 volt. 60 volt. The circuit current is 5 ampere. Everything is given. Calculate the supply frequency and phase angle between voltage and current. What we have to calculate? We have to calculate the supply frequency and the phase angle between voltage and current. So first of all, what I will do? VR. What will be the value of VR? I into R. So what is I? 5. What is R? 10. So it will be 50 volts. So we are having the formula V equal to VR square plus VC square. So basically V square will be equal to under root, not under root, it will be equal to VR square plus VC square. So what will be the value of VC square? It will be equal to V square minus VR square. Now calculate. V is what? 60. 60 square minus VR is what? 50. 50 square. So it will become 33.17 volt. At the end, VC will be equal to 33.17 volt. Now what is XC? XC is equal to, what will be the value of XC? XC will be equal to VC upon I, or you can calculate 1 upon 2 pi FC, but you don't have the value of XC and C. XC can be calculated by this formula, as we know that XC is equal to 1 upon 2 pi F into C, but we don't have the value of F, so we can't use this formula for calculation of XC. Now what will the value of VC? 33.17. And what is the value of current? Current is 5 ampere as it is given in the circuit. So what will be the value of XC? XC will be equal to 6.634 ohms. Clear? Now we will use this formula to calculate the frequency. Now what we will do? 1 upon 2 pi F into C. So what will the value of F? 1 upon 2 pi C into XC. Put the values 1 upon 2 into pi into 400 into, it is microfarad. So what will the value of, and Xc is in ohm, 10 raised to power minus 6 multiplied by what is Xc, we have calculated 6.63. So finally the frequency will come out 60 hertz. It will be the value of frequency, and we have to calculate phase angle phi. So tan inverse Xc upon R. So tan inverse, what is Xc? Xc 6.634, and what is R? R is 10. So finally the value of phase angle, will be 33.6 degree, and what will be the nature? Nature will be leading. Clear? In this way you can solve a question regarding series RC circuit. Okay, thank you.